Hello, everybody. Welcome on the Lights on Data show. Today, we're going to talk about how to optimize data cloud cost. And we're going to do so with Vinoo Ganesh. Welcome, Vinoo.
Thank you so much for having me. Really excited to be here.
It's our pleasure.
Vinoo, can you tell us a little bit about yourself?
Absolutely. My whole career has really been focused on this idea of how to make sense of huge amounts of data, whether that is an operationalization problem, how to use it, whether it's how to manage it from a governance perspective, more recently, how to actually structure it for machine learning or deep learning, or even just how to make use of it in a cost-effective way. So I began my career off at Palantir. I was a software engineer, eventually became a forward deployed engineer, really just focused on solving our customers' data-centric problems. Eventually, I led what was the compute team at Palantir. So all of the open source work, the compute platform itself, before building a data as a service company, really just focused on how we can take huge amounts of data and help people actually make sense out of it. After that, I was at a hedge fund named Citadel. I led business engineering, anything for portfolio managers to generate alpha, and was most recently at a database optimization as well. And now I'm building something new in the optimization space and in the data space.
And I know in the days, months to come, we're going to hear more about it, and we're looking forward to all of that too.
And among other things, so we know that you're also a speaker and that you advise startups too.
Yeah, I think that's been a big part of what has really driven me in the data ecosystem. I think one of the challenges is to really solve data problems at a fundamental level, you need to have exposure to large scale problems. And that comes in two components. It comes in the large scale data itself, having access to data of that scale. And also it comes in the building systems of that scale. So that's where I've been lucky, gotten exposure to a lot of companies, a lot of use cases that combine both of those, especially on the advising front, really just helping companies make sense of their huge troves of data as well.
It will be very interesting if later in the show we can talk about maybe more concrete examples of that. It would be very interesting. But before we do that, can you share a fun fact about yourself?
Fun fact, absolutely. In addition to all of the data and software engineering stuff, I've always really been driven by helping people, which sounds corny, but I like doing it with my really getting hands on and helping out in any way possible. So I actually volunteer as an EMT here in New York. So if you call 911, I may be one of the people responding. I hope I don't see you in that capacity.
Yeah.
We will hope so too.
What's that? Does EMT stand for?
Emergency medical technician.
Wow.
So in an event of an emergency, who are the people that come in trauma or any kind of basic or advanced life support situations?
That's amazing.
That's amazing and crazy
Yes.
and
I really
so
admire
kind.
you for doing that. Yes. So how much time do you invest in that?
It's not too much. The commitment is usually one or two, I guess, tours, is what they're called, tours a month. The pandemic changed a lot of how the entire emergency medical department actually works. And so it's been a little bit more difficult to get really on these tours, just given the demand for first responders. But usually, yeah, once or twice a month. Each tour is about 7 or 8 hours.
Wow.
Thank you for doing that.
Yes, thank you. Given the craziness of that experience, I assume it's an intense, it's everything, it happens fast, everything is an emergency. There's an urgency to it. And to draw a parallel in data with that, whenever you're making use of the cloud, sometimes can spiral out of control as well if you don't watch out. So your costs can really skyrocket. I know hosting our data in the cloud is cheap, but it all adds up. And if we're not careful, it can really go above our means very quickly. So what recommendations do you have for that data cloud cost optimization?
Absolutely. I think one of the things is looking at the EMT parallel. Many folks ask, how do you think under that kind of pressure? And one of the things I think the emergency medical community has done super well is they create these frameworks that just run over and over in your head. And so one of the interesting ones, I think people have heard of like RICE, RISE, ICE, compress, elevate, or FAST, the acronym for strokes. I think one of the interesting things is applying those same frameworks and fundamentals to data management and cost management is one of the areas where there's been relatively little innovation, largely because the landscape, horizontal and vertical, of the data space changes very drastically. You have your vendors, you have your compute platforms, your Snowflake, Databricks, you have the clouds themselves, like the AWS, the GCP, Azure. And so I think one of the really interesting things is anytime you approach one of these problems, I always like starting with a fundamental framework. In any computation problem, especially when we're talking about servers or data, there's three elements. There's network, storage, and compute. Storage is thought of as generally fairly cheap. That's why people move to things like S3. Network is a little bit harder to optimize, especially if you're not the cloud provider himself. So compute is the area that folks spend a lot of time and energy. And that's usually where we start looking. And from the compute perspective, there's generally I like framing it as top down or bottom up. Top down is really what are the platforms or the infrastructure, like the box that everything is running in. Cloud terms, what is the EC2 instance size? In Snowflake, what's the warehouse size? In Databricks, what's the cluster or the EC2 instance that's underlying the cluster? So really like what are you running and what are you running and where are you running it? Then from the bottom up, it's really to focus on the former, what are you running? Like what are the queries that are going into that container? And is that workload actually optimized for that container itself?
Do you then recommend to assign a particular individual as part of the team to keep track of all of this? Or do you somehow implement all these boundaries beforehand that the teams won't go beyond them?
It's a great question. I think if we were to start this process today and also the current state of the world. So broadly, I believe that cost management is everyone's responsibility. And most enterprises, if I took my corporate card and went to the store and spent $10,000 on clothing, probably not going to go well for me, but I can do that right now. I can just run a really poor query that doesn't add any business value, burns through 10K of compute, and no one will think twice about it. So I really think first, the aspect of compute and cost management needs to be everyone's job. Second, I think one of the interesting things is in the data ecosystem, there was this proliferation of capital. So many new data vendors came up, so many new tools. And I think that was a super exciting period. And that led us to where we are right, data driven decision making, people that are actually using concrete metrics or a semantic layer to define business terminology. So I would not trade that for anything. Problem is right now, all of that's very expensive and the horizontal landscape of managing that is really difficult. So I think if we were to do it all over, we would start with the frameworks in the beginning and say, here's what we want to allocate, here's the budget, and so on and so forth. But where we've come, given this proliferation of capital, has actually transformed the data industry pretty substantially.
So, okay, we have the framework. Hopefully, our teams will follow that framework and the best practices that we've set. Let's say we also create a dashboard to monitor anything daily, maybe send us an alert, if something goes a little bit out of whack and spikes up in terms of that cost or potential cost. Are there any other tools that we would be able to use or services that to help us in this journey?
Absolutely. I think one of the most powerful developments in the data ecosystem has been DBT, bringing the idea, the software engineering principles, CI/CD, templatization, even just integration tests to the data engineering landscape has been transformative, both for the mental health of data engineers and for the stability of some of these systems. I think the most powerful thing that enterprises can do is really focus on the open source component. This is not an endorsement of any particular technology or tool, but there's a litany of players out there. Select.dev is a great one. Ian and Niall are super smart, and they are really good about building open source products, specifically into something like DBT. So the modern data ecosystem doesn't have to go procure some incredibly expensive vendor to come in and manage things. It can see a clear open source version of what opinionated best practices are. I also think along these same lines, the idea of sharing best practices is just an incredibly powerful thing that hasn't really been done. If you look at what a cost management or a data cloud management tool largely looks like, it looks like an antivirus. These virus definitions, which are the best practice definitions, and you have these fixed cadence scans, looking over all the queries you're running, your platform, your setup, and then there's alerts that come. This piece of malware was detected in the virus, or this bad practice was detected in the compute world. it's a, if you notice, these are all passive solutions, meaning the ideal case is you don't get a virus on your computer to start off with. Not that you're going back in and saying, let me actually fix this. And so we need to move in the direction of is more active management. So how can I prevent, rather than fire drill and get some scanning software that says this is not going well, how can I get in front of this problem? And how can I have the system itself do the optimization for me? And that's where I hope the industry starts really moving.
Yeah, let's hope we'll start seeing that too. What about, is the onus ever on the provider, the cloud provider, to, do cloud service providers play any help in, yeah, just aiding organizations manage and optimizing their costs?
It's interesting. I think many folks would think that the cloud vendors, concretely, they do profit off of people consuming their product, right? But I think the reality is much more complicated than that. If AWS, if I'm an organization using AWS and my entire budget goes to me using, let's say, Redshift in a non-efficient way, that's actually bad for both my organization and for AWS because that compute capital could otherwise be deployed against probably more business meaningful problems, whether that's expanding my footprint in AWS using S3, EC2, KS, ECS, or expanding my business in other ways that would actually allow me to deeper entrench within something like AWS. So I actually think the onus is it's a really interesting question. I think it's a combination of the consumer of the compute infrastructure as well as the producer of the compute infrastructure. And only through that duality do I think, is there actually a meaningful way to create an optimal capital consuming enterprise?
So if we think about stakeholders from other business areas or from all across the business, how could they be involved in the optimization of the cloud costs?
Absolutely. I think the first question that any financial institution has, or financial wing, I should say, has in an organization, what's my ROI? What's my return on investment? I was chatting with a good friend yesterday. He said we should call it return on data. What's my ROD?
Wow.
And the interesting thing is, if you're talking to technologists, they understand there's a cost. It takes money to make. So there's an inherent cost in deploying your compute capital against a problem and extracting some value out of it. It's much more complicated to explain the ROI when you're maybe not looking at it from a technical perspective. Somebody who has, let's say, $1 million a year of a bill on Snowflake, how can they actually quantify the impact that Snowflake makes on their enterprise?
Right.
And so I think this is where this idea of a semantic layer is going to be really powerful. These specific metrics that are driven by the data that lives in Snowflake, the transformations that exist in your Hex or any of these tools, all the way up until the actual number of daily active users on a screen, that entire pipeline has now become visible to business decision makers. I think that's going to start driving, my speculation is we're going to start understanding the cost of generating these metrics. And as such, the value that these metrics and these dashboards have to the business. And so that's a trend that I think we'll start seeing. It's almost the bringing the real power of analytics to to non-technical users for the first time ever.
And what do you mean by the semantic layer that you mentioned before?
Absolutely. So this is a funny term because it is a very all-encompassing thing. I think of it as nouns and verbs in the data ecosystem. We have semantics is the structure, the way that we speak. The nouns and verbs in an organization dictate both the core objects that the organization cares about. Things like these are the customers and even the relationships. Like these are how the customers are related to the set of orders that actually come in. I think what with the semantic layer, which is still under active definition, what it will be is a way of data engineers, data analysts, and business focused individuals who are able to converge on a common terminology for describing aspects or metrics in the business. In finance, I think it's interesting because some of the EBITDA has a very clear gap accepted principle, knows what that means. There's no negotiating about it. But even terminology that may seem pretty transparent or straightforward, something like a daily active users can mean very different things depending on who's consuming it. And this is a real case. On the side, I help friends do effectively optimization of their own ecosystems. I was working with a company, they've raised $50 million. And one of the really interesting things is this daily active user metric had four different definitions for four different people. And it meant everything from the daily active users, including like API calls, just interesting, or daily active users, meaning who has used the system more than a certain number of times in a day. So actual customers, to just a generic metric of anyone who's used it ever, to who are the humans that are using it. So this term, because of its lack of specificity, is that it's a problematic area depending on who you're talking to. If I use my daily active users, multi log on humans in one slide, and the next slide I change it to every robot and every API call, it's going to look like I 100x my user count, which could be very problematic for the business.
No, absolutely. I think it was this big telecom company in Europe, and they had obviously everybody has issues with some of these definitions. And I remember they were really trying very hard to identify what it means to be a customer, because they had different reports that really were portraying the same thing. But depending on who was providing the report, it had different numbers underneath. And that's because anybody that was dealing with the stores, the brick and mortar stores, they were defining customers as anybody that would purchase like a GSM SIM card that they could put into their phone and use as a one time how many credits that GSM card had. Marketing and sales, because their KPIs were on how many months they have. It's whoever was actually buying a monthly package with them. And there was some other one that I forgot what it was. I think it was how many number of devices they're selling, because then they were equating that with the number of customers, even though sometimes a customer would have two or more cell phones if it was a good deal with them. Anyhow, yes, it's obviously something that's very much needed, and having that semantic layer to provide back the business glossary, the data dictionary back to the business users, as well as the data professionals and the technical staff. It's very much a crucial thing to have.
Yeah, I definitely think one of the things that I'm hoping anytime there's a pullback in terms of like a problem space, meaning data has been proliferated. There's been so much of a horizontal space of vendors, technologies. Now we're seeing the macroeconomic condition result in this pullback. But I think the really exciting thing about a pullback in some form is that it forces people to have these hard conversations around what's actually meaningful. What do we need to operate in a sane and manageable way? Have these conversations around what is a SIM card? What does even the GSM thing actually mean? I think that's a very powerful forcing function for businesses to enact change, and really brings the engineers closer to the business, which is, I think Counter did this incredibly well with the forward deployed engineer model. But having the engineers understand the core fundamentals of the business is fairly differentiated.
So, Vinu, this is a loaded question, my next one, but how do you see the field of cloud cost optimization evolving in the future, and what trends or technologies should organizations be aware of?
Absolutely. I think if you look in 2 to 3 years in the future, compute itself will be commoditized, meaning there's so many players. There's certainly emerging players as well. There's the kind of industry standards of your Snowflake, Databricks, Redshift, BigQuery, MS SQL Server, IBM's DB2, Teradata. But you're seeing this emergence of specialized computing players. Something like a Rockset, it's really great at streaming data, or DuckDB/MotherDuck, which is, I think, going to be really powerful at low cost data analytics, taking advantage of this vertical scaling, to even Fireball. So I think the idea of a workload being componentized and in the queries themselves being deployed on commoditized solutions is the right place that the industry should go. But why does this actually matter? Everyone wants to have a better ROI on their data. And if I'm using a tool that's not fundamentally optimized for my data consumption, that puts me as a user in a pretty bad spot. So I think folks right now who are interested in the cost optimization problem, my honest advice would be talk to people who are industry experts. There are vendors that you could go procure. Again, those vendors are largely, you're going to see the majority of the value in the first day of using them.
Yeah.
Enough usage, and then probably won't see much past that. So I would almost say talk to industry experts and deploy some of the open source best practices. So you get these mostly for free. Again, not that I'm going out there endorsing Select, but I think what they've done, which is starting with a DBT package, is incredibly powerful. It will be universally deployed, and they're able to actually really democratize best practices in this space, which I think is a very powerful place to be.
That's Select Star or Select?
Select.dev. They
Okay.
do a
Okay.
lot of
Thank you.
stuff in the Snowflake space. So let's
Right.
start. Is also a really cool company for several reasons. But actually mentioning them, the idea of data cataloging as a whole is the other really big driving function for
Yeah.
cost optimization. Knowing knowing what to optimize starts with knowing what's even there. And with the proliferation of analytics, you have a ton of dashboards, a ton of data sets that may not have been read in the last year. All of that really compounds together into, let me start with this cleanup of my ecosystem before figuring out what's really needed and figuring out how to optimize moving forward.
Right. Thank you. I want to take a question here, one last question from the audience, and this comes from Dan Everett. And he's wondering, what do you think? Do you have any thoughts on the FinOps Foundation?
Absolutely. I've researched them a little bit. We had someone in a previous conversation bring them up as well. I personally don't have too much knowledge about how the certifications work, but I can say the fact that there's a foundation in aggregate that's actually focused on certifying individuals and understanding the intricacies of how to manage their companies from a efficiency perspective and a technical basis is really powerful and differentiated. A lot of engineers, especially folks who are building these tools, again, the cloud was promised as a environment of free compute. And I think we're seeing on both ends, that's not the case. In fact, recently Azure ran out of compute, like they ran out of capacity. And that was like a very big deal. And so I think the responsible consumption of compute is going to be, and responsible consumption of capital is going to be key. And also the FinOps Foundation seem to do a great job of both of those.
Thank you.
Now, we are slowly coming to a close, the podcast. And I wanted to ask you, Vinoo, is there anything that maybe we haven't covered and you would like to mention? Maybe even a real case scenario that could be inspiring for the audience.
Absolutely. I think one of the most difficult things is, I'll bring this back to the EMT example.
Yep.
Making a small mistake can have a compounding impact on even the care of the patient, kind of in perpetuity. So if you're in an emergency situation and you handle something incorrectly, that can actually compound and result in a serious, for even years. The same is really true in the cost optimization and the management of your data cloud ecosystem. So for break glass or fire drill situations, I've often seen folks who they make a small change, something like we've changed the default size of our warehouse in Snowflake to do a bulk load. Bulk load takes 5 hours. And by the time that this bulk load is done, the engineer's gone home and they come back the next day and they just do business as usual without even thinking about the fact that they've now 10x their fundamental compute consumption. This is a real story. Then many years later, or many years later, people come in and they're like, oh my gosh, you've the delta between what you're actually consuming and what you're paying for is massive. And it's a one-line fix. It can save up to 6 or 7 figures depending on problem space. But that to me is a very key message where small decisions that you make now, especially that's why these best practices of open source land is important. But small decisions that you make now have a huge compounding impact.
No pressure, everyone.
Open source is a good democratization platform of these best practices, or even reaching out to folks like me. You're happy to help. We write blog posts, and these best practices are once you have them written down and once you know them, they're fairly easy to enforce. Again, without spending some obscene amount on a vendor that needs to come in and just keep monitoring and managing.
Right. And thank you so much for all that you do and giving your time to us today and sharing this important best practices and tips and tricks and that you shared. And I do encourage everybody to follow you on LinkedIn and follow the content that you're posting.
Is there anywhere else where people can find you?
I've been writing a Substack called Efficiently. The challenge has been, I put out some stuff that I'm pretty happy with. And then I started building this company and all of a sudden that took up 99.9% of my time. But I'm hoping to shift back a bit and really democratize more thoughts around this. But if I were to give almost a parting thought, I really think the idea of this passive monitoring is probably not the right way to solve this kind of problem. You want to know about problems, the cost optimization problems specifically. You want to know about problems the second that they happen. And passive monitoring has never been able to really accomplish that. So as compute gets more commoditized and almost self-serving, because this is actually something I'm building, if there are ways that you can really deploy technology to get in front of this problem and figure out if you're running the right workload in the right place with the right data, that's a much more powerful place to be than a passive monitoring tool.
Thank you.
Love it. Thank you so much. And thank you very much, everyone, for listening. Have a great weekend and hope to see you soon, Vinu.
Thank you both so much. And thank you, everyone.
Thanks, Inu.